What is ANOVA? ANOVA stands for Analysis of Variance, which is a statistical technique used to analyze the differences between the means of multiple groups or conditions. ANOVA assesses whether the variation in the observed data is mostly due to differences between the groups or if it can be attributed to random variability. ANOVA is commonly used in situations where you have 3 or more groups and you want to determine if there are statistically significant differences among their means. The technique involves partitioning the total variability in the data into different sources, variability between groups and variability within groups. If the variability between groups is significantly larger than the variability within groups, it suggests that there are meaningful differences among the group's means. There are different types of ANOVA depending on the design of the study. One-way ANOVA, used when you have one categorical independent variable factor with 3 or more levels or groups. Two-way ANOVA, used when you have two categorical independent variables factors and you want to assess their individual effects and potential interactions. Three-way ANOVA and more, extensions of the concept to more than two independent variables. The result of an ANOVA is typically presented as an F-statistic and a p-value. If the p-value is below a chosen significance level, often 0.05, you might conclude that there are statistically significant differences among the groups. ANOVA is a valuable tool for comparing group means and assessing whether observed differences are likely due to genuine effects or just random variations. It is widely used in various fields, including biology, psychology, economics, and many others, whenever you need to analyze and compare multiple groups' data. In ANOVA, the essential idea is to compare the variation between group means with the variation within each group. This is achieved by calculating the F-statistic, which is the ratio of the between-group variability to the within-group variability. If the F-statistic is sufficiently large and the associated p-value is below a chosen significance level, often 0.05, you would reject the null hypothesis and conclude that there are significant differences between at least some of the group means. Here's a breakdown of the steps involved in performing ANOVA. Formulate hypotheses, define the null hypothesis, usually that there are no differences among group means, and the alternative hypothesis, that there are differences among at least some group means. Collect data, gather data from each group or condition you want to compare. Calculate variability, calculate the total sum of squares total variability, the between group sum of squares explain variability, and the within group sum of squares unexplained variability. Calculate degrees of freedom. Degrees of freedom are used to calculate mean squares variance estimates. The degrees of freedom for the between groups and within group sums of squares depend on the number of groups and the sample sizes. Calculate F-statistic. Compute the F-statistic by dividing the mean square between groups by the mean square within groups. Determine critical value and p-value. Consult an F-distribution table or use statistical software to find the critical value for your chosen significance level. Compare the calculated F-statistic to the critical value and calculate the associated p-value. Make a decision. if the calculated f-statistic is greater than the critical value and the p-value is below the significance level, you can reject the null hypothesis and conclude that there are significant differences among the group means. ANOVA is a fundamental tool for understanding the sources of variation in data and making informed comparisons between groups. It's important to choose the appropriate type of ANOVA based on your experimental design and data characteristics. Thank you for watching.